Hello students. So in this video segment we shall solve problems related to Maclaurin series. Now to solve problems related to Maclaurin series we have to know what is Taylor series. So the Taylor series expansion for a function of one variable is given by f of x equals f of a plus x minus a f dash of a plus x minus a the whole square by 2 factorial f double dash of a and so on, where the expansion of the function f of x is about the point a. Now if we put a equal to 0 in the previous expression, we get the Maclaurin series, which is f of x equals f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 and so on. And this can be rewritten as y of x equals y of 0 plus x y1 of 0 plus x square by 2 factorial y2 of 0 and so on. So obtain Maclaurin's expansion of sine inverse x up to the terms containing x power 5. So now let us write the expression. So we have y of x equals y of 0 plus x y1 of 0 plus x square by 2 factorial y2 of 0 plus x cube by 3 factorial y3 of 0. So we have to go up to x power 5 plus x power 4 by 4 factorial y4 of 0 plus x power 5 by 5 factorial y5 of 0. Alright, so now y of x equals sine inverse x and put x equal to 0. So for x equal to 0 I get sine inverse of 0, which is 0. Next, what is y1 of x? Differential of sine inverse x is 1 by root of 1 minus x square. So put x equal to 0, y1 of 0 equals 1 by root of 1 minus 0 equals 1. So we have got y1 of 0, which is equal to 1. Now we have to find y2 of 0. That means I have to differentiate y1 of x. Now to differentiate y1 of x becomes difficult because I have 1 divided by root of 1 minus x square. To make things simpler, let me call this as equation 1. Square equation 1. So we get y1 of x the whole square equals, so I'm squaring this term, so you get 1 minus x square. Bring this to LHS. So we get 1 minus x square into y1 square of x equals 1. So I differentiate this with respect to x. So first term 1 minus x square into differential of the second term, which is 2 y1 of x y2 of x plus y1 square of x into differential of this term, which is minus 2x equal to 0. So in this term, let me simplify this. You get 1 minus x square 2 y1 of x y2 of x minus 2x y1 of x the whole square equals 0. So let me call this as equation 2. Now put x equal to 0 in this equation. So if I put x equal to 0 and you have y1 of 0 equals 1. So you have 1 minus 0 into 2 into y1 of 0 is 1 into y2 of 0 minus x is 0. So this term becomes equal to 0. So I have 2 y2 of 0 equals 0, or y2 of 0 is nothing but equal to 0, right? So therefore I've got the next value of y2 of 0, which is equal to 0. So let me write all the values here. Y of 0 is 0, y1 of 0 is 1, y2 of 0 is 0. Now I have to find y3 of 0. To find y3 of 0, let me again differentiate equation 2. Now we can simplify this expression because I have 2y1 x common. So divide the whole expression by 2y1 of x. So we have 1 minus x square y2 minus 2y1 of x gets cancelled. So I get x y1 equals 0. So here instead of writing y2 of x and y1 of x, I'm just writing y2 and y1 so that it becomes easier. So y2 is nothing but y2 of x, y1 is nothing but y1 of x, right? So now we differentiate this again with respect to x. differentiate expression 3. So the first function 1 minus xy, differential of y2 is y3 plus y2, differential of the first term is minus 2x minus first function into differential of second function is y2 minus y1 into differential of x is 1 equal to 0. So you have 1 minus x square into y3 minus, you have 2x y2, 1x y2, so it becomes minus 3x y2 minus y1 equals 0. So here put x equal to 0. So I have 1 minus 0, y3 of 0 minus x is 0, so this term becomes 0, minus what is y1 of 0? y1 of 0 is 1, so I have 1 equal to 0. So y3 of 0 is nothing but equal to 1 again. So let me write here y3 of 0 is equal to 1. So I have to proceed all the way up to y5 of 0. So we have this previous expression. I have to differentiate this again with respect to x. So first function, that is 1 minus x square into differential of y3 is y4 plus y3 into minus 2x, differential of this, minus 3x into differential of y2 is y3 minus 3 y2 differential of x is 1 minus y2 equals, so we have 1 minus x square y4, so this is minus 2x y3 minus 3x y3, so it becomes minus 5x y3 minus 4 y2 equals 0, minus 3 minus 1 gives minus 4. So now put x equal to 0 in this expression. So you get 1 minus 0 into y4 of 0 minus 0, because x is 0, minus 4 into what is y2 of 0? 0 equals 0. So you have y4 of 0 is also equal to 0. So y4 of 0 is equal to 0. So we have this expression. So this expression is again differentiated with respect to x because we need y5. 1 minus x square, differential of y4 is y5 plus y4 into minus 2x minus 5x, differential of y3 is y4 minus 5y3, differential of x is 1 minus 4 y3 equals 0. So you have 1 minus x square y5. So you have minus 2x y4 minus 5x y4, so it becomes minus 7x y4 minus 5 minus 4 is minus 9 y3 equals 0. So now put x equal to 0. So you get 1 minus 0 into y5 of 0 minus x is 0, so this term is 0, and then minus 9 y3 of 0 is 1 equal to 0. So therefore y5 of 0 is nothing but 9, right? So y5 of 0 is 9. So let us use all these values in this expression to get the Maclaurin's expansion of sine inverse x. So it is very convenient if we write all these values separately so that we can substitute them in the expression and get the answer. So y of x is nothing but sine inverse x equals y of 0 is 0 plus x, y1 of 0 is 1 plus x square by 2 factorial is 2, y2 of 0 is 0 plus x cube by 3 factorial is 6, y3 of 0 is 1 plus x4 by 4 factorial into 0 plus x power 5 divided by, so we have 5 factorial, right? So 5 into 4 into 3 into 2 into 1 into 9. So this is 0, so you have x plus this is 0, you have x cube by 6 plus you have 3 3s are, so it is 3x power 5 divided by 5 into 4 is 20, 20 into 2 is 40. So finally we get the answer sine inverse x equals x plus x cube by 6 plus 3x power 5 by 40. The next problem, obtain the Maclaurin series up to terms containing x power 4. So the function y of x is nothing but e power sine x. So you have y of x is nothing but y of 0 plus x y1 of 0 plus x square by 2 factorial y2 of 0 plus x cube by 3 factorial y3 of 0 plus x power 4 by 4 factorial y4 of 0. So I have y of 0, which is e power sine 0, which is sine 0 is 0, e power 0 is 1. So y of 0 is 1. So let me write y of 0 equals 1. Next, what is y1? y1 is nothing but differential of e power sine x. So it is e power sine x into differential of sine x is cos x, right? So what is y1 of 0? So instead of writing y1 of x, I'm just writing y1 here. So therefore this implies, what is y1 of 0? It's e power sine 0 into cos 0. So e power sine 0 is 1 into cos 0 is 1. So the answer is 1. So therefore y1 of 0 equals 1. So now this expression y1 can be written as e power sine x is nothing but y, and then you have cos x, right? So now let me differentiate this expression once again. So y2 equals first function y into differential of cos x is minus sine x plus cos x, differential of y is y1, right? So what is y2 of 0? It is y of 0, which is 1 into minus sine 0, which is 0, plus cos 0 is 1 into y1 is 1. So this is 1. So y2 of 0 is 1. So y2 of x is nothing but minus y sine x plus y1 cos x. So I differentiate this again. So y3 equals minus y, differential of sine x is cos x plus sine x, differential of y is y1 with a negative sign plus y1, differential of cos x is minus sine x plus cos x, differential of y1 is y2. So you have minus y cos x, and then you have minus 2 y1 sin x plus y2 cos x, right? So you have minus, so if you put x equal to 0, therefore y3 of 0 is nothing but y of 0. What is y of 0? 1 into 1 minus 2 into y1 of 0 is again 1 into 0, sine 0 is 0 plus y2 of 0 is 1 into 1. So you get minus 1 plus 1 equal to 0. So we have y3 of 0 equals 0. So I differentiate this expression y3 once again because I need y4. y4 equals differential of cos x is minus sin x into minus sin x plus cos x, differential of minus y is minus y1. Then you have minus 2 into y1, differential of sin x is cos x minus 2 sin x, differential of y1 is y2 plus y2, differential of cos x is minus sin x plus cos x, differential of y2 is y3. So here you put x equal to 0. So you get y4 of 0, which is, so if I put sine 0, the first term becomes 0 plus cos 0 is 1 into y1 of 0 is 1, so minus 1 minus 2 into y1 of 0 is 1 into cos 0 is 1 minus sine 0 is 0, so this becomes 0 plus this also is 0 because I have sin x plus cos 0 is 1 into y3 of 0 is 0. So we have minus 1 minus 2, which is equal to minus 3. So y4 of 0 is minus 3. So let us substitute all these values in this expression. So we have y of x equals, what is y of 0? 1 plus x, y1 of 0 is 1 plus x square by 2, y2 of 0 is 1 plus y3 of 0 is 0 plus x power 4 by 4 factorial. So which is 24 into minus 3. So 3 1s are 3 8s are. So we get, so the final expression y of x is nothing but e power sine x equals 1 plus x square by 2 minus 1 by 8 into x power 4. So this is the final expression. So obtain Maclaurin's expansion of root of 1 plus sine 2x up to x power 4. So we have y of x equals, so this is the Maclaurin's expansion up to x power 4. So I have y equals root of 1 plus sine 2x. Now this has to be simplified and rewritten in such a way that it becomes easier for us to find the differentials of y, which is y1, y2, y3 and y4. Now 1 can be written as root of sine square x plus cos square x, right? So 1 is nothing but sine square x plus cos square x plus sine 2x can be written as 2 sine x cos x. So this is of the form a square plus b square plus 2ab. So therefore this is nothing but sine x plus cos x the whole square, the whole root. So I have y equals sine x plus cos x. So now what is y of 0? It is 0 plus 1, which is 1. So y of 0 equals 1. What is y1? y1 is differential of sine x is cos x. Differential of cos x is minus sine x. So y1 of 0 is cos 0 is 1, sine 0 is 0, so it is 1. So y1 of 0 equals 1. y2 is nothing but differential of cos x is minus sine x. Differential of sine x is cos x. So it's minus sine x minus cos x. So therefore y2 of 0 is, this is 0 minus 1. So y2 of 0 is minus 1. Next, y3. y3 equals differential of sine x is cos x, so it is minus cos x, but differential of cos x is minus sine x, so the sign changes, so this becomes plus sine x. So y3 of 0 again is equal to minus 1. So we have to differentiate this again. So y4 is differential of cos x is minus sine x, minus into minus is plus, so you have plus sine x plus cos x. So y4 of 0 is nothing but 0 plus 1 is 1, so y4 of 0 is 1. So very simple problem. So now let us substitute all these values in the expansion. So we have sine x plus cos x equals, what is y of 0? 1 plus x into 1, and then you have y2 of 0 is minus 1, so it is minus x square by 2. Then y3 of 0 is also minus 1, so it's minus x cube by 3 factorial is 3 into 2, which is 6, plus x power 4 into 1, y4 of 0 is 1, 4 factorial is 6 into 4, which is 24. So this is the final answer. So sin x plus cos x, or this is nothing but equal to root of 1 plus sin 2x. Right? So we actually simplified root of 1 plus sin 2x as sin x plus cos x. So sin x plus cos x is nothing but root of 1 plus sin 2x, which is equal to 1 plus x minus x square by 2 plus x cube by 6 plus x power 4 by 24, and so on. So we have been asked to find the expansion up to x power 4, so we have stopped. So in the next lecture session we shall solve some more problems on Maclaurin series. Do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.